Well, here we go, guys. We're going to start the Mobius Seaview, the 4-window version, which is, of course, from the TV show. And we're doing this for Jim. I know he's chomping at the bit here. Bob Martin built him a really nice Nautilus, and Bob was so busy.
Nautilus?
Yeah, he built him a Nautilus, and one about that big, radio controlled, and he loves it. Now he just has to have the Seaview, because obviously the Seaview complements the Nautilus, because they're two of the most famous sci-fi science fiction subs of all time, and who wouldn't want to have both? I know I do, and I do have both. This is the kit here. We've talked about this before, that we were going to do it. He's put together a few things already. He put on the front window, which never does fit good. So there's a big seam there I have to get rid of. But he's also pre-cut. He's put the two halves of the sub together. Now, those of you that are familiar with mine realize that with mine, these two sections come apart to get the cylinder in and out. But on this one, the deck gets cut, the deck. See, like so. So that way the cylinder can come in and out through the top pretty easily. Hardly any effort at all. So that was the David Merriman concept, and it works very well. All these parts are David Merriman's add-on or aftermarket parts he designed. And I've started some of it because I wanted to familiarize myself with how his parts work as opposed to the way I built mine with the Big Dave cylinder, which mine was all built out of the box. I converted all their parts, all their appendages, into functional appendages, whereas Dave Merriman gives you, like, for instance, these are sailplanes, and these are the fillets that fit to them. I've got it backwards, like so, around the sail, and they've already have their little pins in them and everything so that you can add to brass and they will turn. And so, you know, he remade the dive planes. So the dive planes fit around the rudders because the rudders on this one move, not like a static model. And he's made new rudders for it as well. And so what I'm going to do now is show you how all this stuff works. I just lost my rudder pin. Stick this back in. Oh yeah, that went through here. That's right. Okay. So it took a while to figure all this stuff out. Not that long, but it's basically the same as what I did with mine. I temporarily tacked in the pump jet, which for some reason feels real stiff, but I think once I put some oil on it, it'll be fine. Feels very stiff, in fact. Well, there it goes. It's just the angle I'm at. What will eventually happen with this is that there's going to be a dog bone coupler hooked up to this like this, and this will have a shaft on it, and that will turn, and it can move at any angle. Because once these are attached to the inside, the actual shaft to the, I think I can sort of demonstrate this here, the shaft to the prop shafts will actually be able to turn at an angle. If I can get this to go in the slot. Oh, come on. I should screw it down. You see how I can turn that at an angle? Yeah, it'll still turn the propeller inside, and no matter what angle I'm at, I'll still be able to turn it. So that's why we use what's called dog bones. So here's the dog bones that will go on the other end, up towards the cylinder, which is right here. So when this could be at an angle like this and still turn, or it could be straight on and turn, or it can be this way and still turn. So that's why we use the dog bones. It's basically a universal joint, but they call them dog bones. So, and they're on both ends. So I temporarily tacked this in, and this is at a very specific angle. And the reason it's at this angle, you see this little hole right here? Should you ever have a problem in this little grub screw to the propeller come loose after the fact that this has been closed up and in the model, and I'll put this in basically, you see that hole there? I'll still be able to get to it. Can you see that, Mary? So the other thing that I did is I had to take the rudder here and I had to drill a hole all the way through this. And I'll show you how I did that in a second. Also, I had to drill, well, actually, this hole was already drilled. This is the one that was tricky because you have this piece that David has made, which controls all three rudders because they're gang-banged together. Maybe that's not a good term, but they're all ganged together, okay, on one skeg. So, and you can see it turn there so it moves freely. And I'll show you how this works once it's inside here. Okay, so once again, I'm going to put this in. That's facing the wrong way. It goes in right in there. You see how you had to grind away all this too. I'll show you that in a second. This goes like that. Sometimes you need 4 hands in this hobby, I swear. There we go, all the way through. There. So, and then it came out again because it's going to do that. I'll turn it side so it's less likely to fall out. So, there we go. So that controls the rudder very nicely. So the next challenge that I'm working on is you get one nacelle done and then the other one goes very quickly. It's very much like building the wing of an airplane. Once you get one wing built, the other one goes together really fast. What I want to do is figure out, and I was just starting to work on this, and I said, you know, I should start showing them now what's going on. Now, this is the dive planes, which directs the thrust coming from the pump jet up and down, so the submarine can go up and down. But there's a bunch of garbage here that's on here from when this was a display model, and to capture their parts. Okay, so we need to get rid of that in order to have these be able to move freely. So I'm going to grind this stuff off. I'm going to turn it up a little bit more. Where would this hobby be without a Dremel tool? Okay, so we should have, this should fit in there very easily now. Because now we have to figure out where we're going to put pins in it so that it'll turn. Now basically, I'm not going to put a pin on the outside. I didn't do it with mine. I just drilled it on the inside, and then I have a rod going all the way through and through here and out to the other one. And into the other dive plane. So, but that goes right about there. And I can just see where things go. So I'm going to make a little pilot hole right here. And when you're drilling through styrene, never use the correct sized drill bit to make your pilot hole or your hole, because it melts the plastic even at a slow speed like that, and the hole will get bigger. Theoretically, now I should be able to pass this through. Yep, very successfully. And that hole was definitely a smaller size than, I'm going to tape this together. The drill bit I used was definitely a smaller size than the diameter of the shaft, and after I drilled it, it was exactly the perfect fit. So it just goes to show you this stuff, and this is styrene. It melts, so the hole gets a little larger. And it's better to use low speed when you're drilling through there, right, Elliot? That's why we use the Tamiya drill a lot. Because that was something Tom Piedmont taught me about, and he said, Steve, that won't burn or melt the plastic. So, okay, so here we go. Yeah, that's some kind of language, I'm not sure which, for putting in the rudder. If I can just get this to go into the hole, Basically, I'm just going to feed this into the pilot shaft there. Eventually it'll get glued in, and you can see how it turns very freely. But what I have to do now, of course, is drill a hole on the other side for that to go into. I think I'm going to do it that way after all. Let's be a little bit more supportive. This should make a mark. It did rather successfully. Made a mark. So, okay, so now I just need to get this apart and open that up a little bit so it'll go in. Where's my drill bit? Because it's really quite hard to, not unless maybe if I just make this longer. Yeah, really, huh? So being really clever here, it doesn't reach. That's such a drag. I wish I had a longer bit. Let's try again. A little further. I only need to go in just ever so slightly to that side. Come on, reach. I sort of made it. Let's see if I can go a little further. I'm right at the end of this bit here. Well, it worked, and then it came loose. So let's see. What did I do with my rudder? There it is. And I had a pin for it. There it is. Let's see if that goes all the way through. Actually, I can just do that now, can't I? There we go. This is why submarines are one of the harder modeling. There, perfect. That just got such good movement to it. It's nice and even, and so once I glue the actual shaft into the dive plane, and it will move across this way through to the other one. It'll move both of them. There'll be a, where is it? I think this is it here. This will be hooked up to it, and there'll be a ball joint hooked down there that comes through and hooks to our control here and moves it, something along that line. So, so now that's in, that's good. I want to get this back in and make sure that I have the clearance there, that I'm not leaning too far forward. Probably help if I tape this back together. And now I'll have all this figured out, and there will be no mysteries, and I can build the other side very, very quickly. We've got our rudder movement, and we've got our up and down elevator movement. So here we go. That's glued onto the shaft. So theoretically, I can just set this in here like so. And we have up and down. Oh, look at that. Isn't it wonderful? And then I glued this inside of this because it occurred to me I don't need to, I can just grind those off at the end once they're in here. It'll stop falling out, but it'll still turn inside the pilot hole here. So there we go. So there, now close. Okay, so we've got turning. Well, it's hard to turn the pump jet because I can't get my hand in there, but we've got right and left, and we've got up and down. Isn't that nice? And right and left. Now all I have to do is do this to the other side. And I'm going to show you what I did. Well, also I got this to do. This is the, you use the exact terms here. Skeg rudder. That was the term I was looking for. There's really no instructions here, although I do know Merriman has, as usual, some sort of instructions on the net. So So it goes this way. And it's not lining up with his part. His part's very handy. Let's see if I can get it out of there. Here fits right down in there. And I think that's the part I thought I was missing. Yeah, it was. Yeah, this is for the rudder. So now I know where it went. And that fits just perfect in there. I mean, just look at that. Right to this, where this fits. So this is so that we can hook up the rudder and have a very reliable and secure shaft running through it. And we're going to be using this brass here to go through that, which should go through there and turn very easily. In fact, does. And then, of course, this fits into the skeg rudder. It does very perfectly. And then eventually, one of these will hook up to here, and the control rod going to the cylinder moves all three rudders. But first I have to get it to fit, and the way this is right now, we're not, I'm going to cut a piece of this. I'm going to cut off a piece. And deburr it. I think that end's already deburred. And run it through here and see where it comes out. It comes out very cleanly right there, but I can see already that it's not going to quite fit. So that means that I need to remove some of this material here. You can just see how that plastic melts, the styrene melts, and it just, it doesn't take much temperature to melt it, but then this piece will just come right off. And I'm noticing that it's kind of at an angle, and that's kind of interesting because it really shouldn't be. So I may have to do some adjusting on this part. I don't know how much, but there really shouldn't be an angle like that. So after messing with this a while, drill the other side, got the other rudder in place, and I just temporarily hooked up a little piece of wire here, Z-bend it, so you can see how freely the rudders move. So this is more than enough to make this turn. I probably could get a little more out of it, maybe, but it's pretty much the limit. So I know that on mine, this is more than enough. You've got three rudders there, and you've got the water thrust coming right out over them. So it's very effective in turning this this model. Down here we've got these, which this one's not glued on yet, but these go up and down, and there'll be a control inside that that's inside here that goes back and forth. In other words, there'll be a piece of brass, like a horn, coming up. This is long bar with a hole in it, attached to this little piece of brass here, and the servo pulls it in and out. So that worked out really, really well. I'm really pleased with that. Everything went together as it should. It turned out that you had to remove a lot of material here to get this to be level, and lined up with that. The more I do it, the more it makes sense to me. Okay, so the next step I'm going to do, but not today, is to hook up these forward dive planes. This part goes in from the inside. I cut this out here, okay, and then this goes in and seats up against here, and I make this all flush, remove the original part, and replace it with this one. So it ends up being able to move like this and give you some dive plane action there. How that's moved is that there is a coupler here that goes to a rod like this, which will run across from one side to the other, and this fits over that rod and gets attached. There's a set screw in there, and this should fit right over here. It does, and then that does this. This is magnetic. So when you remove the cylinder or take the top off, you can just release it magnetically, and it's strong enough to actually move those planes, since there's not a lot of resistance. And what happens on the business end here is how you get to that little part moving way up in the front is you have this part here, which connects to the dive planes. So the dive planes in the back that cause you to go up and down in your pitch connects to a rod. Piece of rod goes on here like this, goes all the way up to the front, and of course it's soldered to this. So both these magnetically connect, and now when the rear dive planes move, the front dive planes move. So it's pretty cool. Rudder, dead easy. There's the rod going from here to there. Of course, the actual dog bones go this way to drive both the propellers inside, and that's about it. But there's still a lot to do. But it's going along really well. We got a good start on this model being built. I've got the whole business end working, which is great because that's the hardest part. So it goes very smoothly from here, and I'm looking forward to it.